there is an interesting topic in additional mathematics known as double angles. Okay, so it will be very inappropriate for us exceeding without greeting each other. So I greet you all, and you are most welcome to our today's lesson, which is the double angles in additional mathematics. So under double angles in additional mathematics, there are three identities which you should know. So make sure that you master these three identities for you to be solving questions on the double angles easily. Without these identities, you're going to have difficulties in solving questions on the double angles. And questions on double angles usually comes in exam questions. Okay, so the first identities which we had on the double angles is sine 2a. So sine 2a is equals to 2 sine a cos a. So this is the first identity which we have under double angles. Okay, so, and the second one is cos 2a, which is equal to, so this is cos 2a is equals to cos a squared minus sine a squared. The last one, it's tan 2a. Tan 2a. So tan 2a is equals to 2 tan a divided by 1 minus tan a squared. Okay, so let's just elaborate more on this. So sine 2a is the same as sine multiplied by a plus a. Okay, and this will give us okay, so let me just write it here so that we understand clearly. So sine 2a, we have said that sine 2a is the same as sine a plus a, which will give us sine a cos a plus cos a sine a. If you see this, they are like terms, so you can add, and so you're going to have 2 sine a cos a. Okay, and this is the same as this one which we wrote on top. Okay, so writing as sine a is the same as sine 2a is the same as this, writing like sine a plus a, because a plus a to give us 2, and so we're going to have sine 2a. Okay, so this is how they came up with the identity of sine 2a. Let's now look on cos 2a. So cos 2a is the same as cos a plus a, okay, which will give us cos a cos a. So for cos we multiply this multiplied by this, cos a minus sine a sine a. Cos a multiplied by cos a, it will be cos a squared, and sine a multiplied by sine a to be sine a squared. So here we're going to have cos a squared minus sine a squared. So this is how they came up with that. Okay, so this is these are the identities that you should know when you're dealing with the double angle. So make sure you master these three identities. So number one, we have this one, which is sine 2a is equals to 2 sine a cos a, and number two, we have cos 2a is equals to cos a squared minus sine a squared, and the last one, which is tan 2a is equals to 2 tan a over 1 minus tan a squared. So this is 1, this is 2, this is 3. So make sure you master these three identities, okay, on a double angle. So let's try to see how questions are phrased on this kind of topic, which is a double angle. So we have this question. So activity 1. Okay, so we can write activity 1. Okay, activity 1. So this question, given given that sine, let me just change the marker. So given that sine A is equals to 4 over 5, where 0 degrees is less than A and A less than 90 degrees, where 0 is less than A and A less than 90 degrees, and we have been told to find, so find the values of A. Question A, we have sine 2A, and question B, we have cos 2A, and this is C of tan 2A. Okay, so this is the question. So I'm going to repeat our activity. So given that sine A square, or given that sine A is equals to 4 over 5, where 0 degrees is less than A is less than 90 degrees. Find the values of A sine 2A, B cos 2A, and C tan A tan 2A. So like we know that any or every math problem has a solution. So this is our solution. Okay, so let's begin by answering question A, because it's the first question. Okay, so we know that sine 2A, okay, we know that sine 2A, so this is sine, is equals to 2 sine A cos A. Okay, so if you see here, it's easy for us to replace in this part if we know cos A, but we don't know what cos A is. So we can find cos A, but how can we find cos A? So remember, on your identities we had this kind of equation where it's like this, sine theta. So let me just highlight it. So sine theta squared plus cos theta squared is equals to 1. Okay, so this is the equation that we are going to use for us to find cos A. So we also know that sine A squared plus cos A squared, it will give us 1. Okay, so let's now find cos A, since we know what sine A is. We have been given sine A, which is 4 over 5. So we can write sine A, which is equals to 4 over 5, so that we don't forget. Okay. Okay, so we are going to have sine A squared. You are going to use this one, sine A squared plus cos A squared is equals to 1. Where there's sine A, we put this one. So we're going to have 4 over 5, because that's sine A, but remember here it's squared, so we're going to square this. We're going to square this, okay, plus cos A squared is equals to 1. Okay, let's now expand this. So here we're going to have 4 squared, it's 16. So we're going to have 16 over 5 squared, which is 25, plus cos A squared, which is equal to 1. Having reached this side, you can now collect the like terms where you take this to this side. So we are going to have cos a squared is equals to 1 minus remember when a number crosses the equal sign, its sign changes. So here to be negative 16 over 25. Then we find the common denominator. So here if you find the common denominator, we're going to find that it's 25. So we're going to have cos a squared is equals to 25 into 25, it's 1 multiplied by 16. So we're going to have 16 here, and 1 into 25, it's 25. So here there's 1 into 25, it's 25 multiplied by 1, we're going to have 25. Remember there's a minus here. Okay, and this will take us to this stage where we'll be, well, of course, a squared is equals to 25 minus 16, it's 9 over 25. Then we make cos a the subject formula by introducing the square root. So we're going to have the square root here, even here the square root, this and this. We know that the squared and the square root cancels. So we're going to have cos a is equals to square root of 9, it's is 3, and the square root of 25, it's 5. Sorry, it's 5. So this is cos a. So having found what cos a is, it's now easy for us to find cos. It's now easy for us to find sin 2a. So I found cos a to be. So we can take note of this. Cos a is equals to 3 over 5. So we have sin a here, which is 4 over 3. Let's now find what sin 2a is. Okay, so we know that sin 2a is equals to 2 sin a cos a. So here we are going to have 2 multiplied by sin a, it's 4 over 5 multiplied by cos a, which is 3 over 5. We have found this, and this we are given in our question. So here just do the multiplication. So we're going to have 2 multiplied by 4 multiplied by 3, it's 12 over 5 multiplied by 5, which is 25. Okay, then here you also multiply. So we're going to have 2 multiplied by 12, it will give us 24 over 25. So this is sin 2a. So we can conclude that sin 2a is equals to 24 over 25. Okay, so this here is sin 2a. So let's now find what cos 2a is, because we have 3 questions. We have only found question A, which is sin 2a. So this we have found, and we have found that the answer is 24 over 25. This is A. Okay, B, which is cos 2a. So cos 2a, we know that cos 2a is equals to, what is cos 2a? Cos 2a is equals to cos a squared minus sin a squared, according to the identities on a compound angle. So we have sin a, which is 4 over 3. Also have cos a, which is 3 over 5. Okay, we can just replace in this identity which we have. So we're going to have cos 2a is equals to cos a squared. Where there is cos a, we'll replace this. So 3 over 5. Remember it's squared, so don't forget to square. Minus sin a, which is 4 over 5. You also square this. So 3 squared, it will give you 9. So we are going to have 9 over 25. Okay, 9 over 25 minus 4 squared to give you 16 over 5 squared, which is 25. So we're going to have a cos 2a is equals to, here the common denominator is 25, so we have 25 down here, because this and this, they're just the same, so the common denominator would be just constant, will maintain itself. 9 minus 16, which will take us to this, cos 2a is equals to 9 minus 16 is negative 7. Remember, you take the sign to the bigger number, from the bigger number, which is 16 there, over 25. Okay, so this is cos 2a. So cos 2a is negative 7 over 25. We found sine 2a, which is 24 over 5. This one, 24 over 25. This was A. And question B, we have found negative 7 over 25. So this is cos 2a, and this is sine 2a. So let's now find tan 2a. Tan 2a. So we know that tan 2a is equals to 2 tan a over 1 minus tan a squared, okay, according to our identities which we wrote down there. Okay, so you should know that tan a is the same as sine a over cos a. On the trig ratios, I mentioned this, where we have sine theta over cos theta, which will give us tan theta. So writing as sine a over cos a is the same as writing as tan theta. So in this case, we're going to use this one to find tan theta. So let's find our tan a. So tan a is equals, so I've said that tan a is the same as sine a over cos a. So what's our sine a? Our sine a, it's 4 over 5. Divide our cos a, which is 3 over 5. So when do you know that division sign changes to multiplication sign, and when it does that, the denominator and the numerator cancels each other. So we're going to have 4 over 5 times 5 over 3, which this and this will cancel, and so we're going to have 4 over 3. When the division sign changes to multiplication, the numerator and the denominator swaps. Okay, so we're going to have our tan a. So this is tan a, which is 4 over 3. So we can take note of this. So we can say that our tan a is equals to 4 over 3. So let's just now replace in this identity. So we know that tan 2a is equals to 2 tan a, and tan a were found to be 4 over 3. Okay, like this. So these two multiply with this in the bracket. Divide. Okay, this division line is the same as in this. Divide 1 minus tan a squared. We know that tan a is 4 over 3, so we're going to have 4 over 3. But remember, here it's squared, so here we are going to square. Okay, so when we square, we are going to have 2 multiplied by 4, sorry, we're going to have 8, okay, over 3, 8 over 3. Okay, divide 1 minus 16 over 9. Then here we find the common denominator. So of 8 over 3, divide the common denominator, I mean the number which this and this can go into without leaving any remainder. So this number is 9. 1 into 9, it's 9. 9 multiplied by 1, we're going to have 9 minus 9 into this, it's 1. 1 multiplied by 16, it's 16. And so we're going to have 8 over 3, divide 9 minus 16, it's negative 7 over 9. Okay, then having reached this side, we just now change the division sign into multiplication sign. And when we do that, this will go on top and this will come down. We know that the numerator and the denominator swap. So we're going to have 8 over 3 multiplied by 9 over negative 7. So this and this 3 can go into 9 3 times. So we're going to have 8 multiplied by 3. It will give us 24. So tan 2a is equals to 8 multiplied by 3. It's 24 over 1 multiplied by negative 7, which will give us negative 7. So this is what tan 2a is. So we have solved our question on A, or on the first question we are told to find sin 2a. We found the sin 2a, it's 24 over 25, and B, we are told to find cos A. We found negative 7 over 27. Yes, the last part, which is tan 2a, we have found tan 2a to be 24 over negative 7. So this is all about double angles. Make sure you just know those identities that have given down there. Make sure you master those, because if you don't, you're going to have difficulties to be guessing, because you can't guess this. So we are a school of online lesson. If you feel like you're interested, you can reach us using this line, plus 260 9 70 11 11 36. Okay, so if you're watching this on YouTube, give it subscribe, or if you're watching this on YouTube, subscribe, and if you're watching this on TikTok or Facebook, give it a follow and a like. Have a blessed day. I greet you